Hi guys, today we are going to work a couple of problems on our Unit 9 test review. The first one I'm going to go over is number 3. So this is my equation in vertex form. The way I know it's in vertex form is f of x equals a times x minus h squared plus k. The reason we really like vertex form is because we can see what our vertex is. Remember, your vertex is the h value, which is inside the parentheses, and we always do the opposite of anything inside the parentheses, comma, the k value, which is my constant out to the side. So I see a 3 in the parentheses with x, which makes it a negative 3. Because it's inside the parentheses, we always do the opposite of what's inside the parentheses. The 8 is not in the parentheses, so we're just going to say our y value of our vertex is 8. So that's how you can just look at your equation in vertex form and find the vertex. The next thing we're going to look at is determine whether this opens up or down. The A sign tells you if it opens up or down. Since A is negative, you're opening down. If A is positive, you would open up. Once we find the vertex, we can then find the axis of symmetry. Your axis of symmetry is just a vertical line that separates your parabola into two symmetrical halves. There's an x in the word axis, so we know that it's x equals, and it's just the x value of your vertex, because the axis of symmetry goes through the vertex. Sometimes it's hard to determine if we have a min or max just looking at the equation, but we said that our parabola opens downward, so it opens like this, meaning that that is a top point. If that's a top point, that's a maximum. So I'm going to circle that it's a max. And when we're talking about up and down, that's vertical. Your vertical axis is your y-axis, so we use our y value of our vertex. My domain for all quadratics, unless you have endpoints, is all real numbers. Your domain for all quadratics, unless you have endpoints, is all real numbers. And then the last one, range. Range is y. Since I'm opening down, my y values are small, meaning I'm going to use my less than or equal to sign. And again, it's just the y value, since we're doing range, it's the y value of my vertex. So whenever you have your equation in vertex form, it's really easy to find your most important point, which is your vertex. You just have to be careful. You always take the opposite of what you see inside the parentheses with x. Okay? So that's doing one that's in vertex form. Now we're going to look at one that is graphed already for us. I will tell you, you're going to have one super similar to this on your test. This is not going to be multiple choice, and you're going to have to fill all of this in. Okay? So, does this parabola open up or down? Just like the last one, the opening's at the bottom, so this opens down. Your vertex is your high point or your low point, so my vertex is right there, which is at 3, 8. Remember, axis has x in it, so it's always x equals the x value of your vertex. Now, is this a top point or a bottom point? Is that vertex a min or a max? It's the top, so that's the maximum value. And again, your min and max always happens at the vertex, and we're talking about height. Y is your height value or your height axis, so it's just the y value of the vertex. Your domain is always all real numbers. Because see how this parabola goes off the graph? It's not stopping. Your range is always y. Again, just like the last one, this one's going down, so we're going to do a less than or equal to the y value of your vertex. And then one that this also has is what is the X-intercepts? So we're going to go across the x-axis and look and see where does my parabola hit the x-axis. It hits right there. So that is at 1, 0. And it also hits right there, which is at 5, 0. It also could ask you for your y-intercept. This graph is kind of hard to see because it's kind of smushed down here. I would say it's right there at 0, -9. Remember, x-intercepts are always x, 0. Y-intercepts are always 0, y. Other words you can use for this x-intercept are roots, zeros, and x-intercepts. All of those mean the same exact thing, where the parabola hits the x-axis. Okay, so that is our identifying our attributes from equations and from graphs. Now we're going to actually graph some of these. Okay, so we're going to do number 7. This is in vertex form, so I should be able to find my vertex. Remember, your vertex is always the x value in the parentheses with x, comma, the constant out to the side. So my vertex is at the opposite of -1, which is +1, comma, 3. So I can put a dot at 1, 3. Now, we can plug in more values into our equation for x to find the corresponding y values. Or you can just go to your calculator, and I'm going to type in the equation I see. Make sure you type it in exactly as you see it. So -3 times x minus 1 squared. Make sure the squared is on the outside of the parentheses, just like it is in your equation that's given to you. And then we're going to pull up the table. I know my vertex is at 1, 3. So I want to plot a point right next to that. So I'm going to plot the point 2, 0. And then another point right next to that would be 3, -9. Well, I can reflect those points over my axis of symmetry, which we haven't drawn yet. Remember, your axis of symmetry is a vertical dashed line that goes through the vertex. It cuts your parabola into 2 symmetrical halves. So this point is 1 away from the vertex, so I can go 1 away to the left. This one's 2 away from the vertex, so I go 2 away to the left. Also, you can just find more values. I know, again, my vertex is at 1, 3. Instead of finding points below it, I could go above it and plot a point at 0, 0, which is what that point is. And then I also could plot a point at -1, -9, which is that point. Don't forget to actually draw the parabola and always put arrows at the end. Okay, so that is how we can graph. Remember, you can use your graphing calculator to help you graph, but it is super important that you find your vertex first, so then you know where on your table to look to find other values to graph. Okay? Next, we're going to move on to some transformations. Okay, whenever we are transforming, it's super important to list out your starting values for your A sign, A value, H value, and K value, and then your new A sign, A value, H value, and K value, because it makes it a lot easier to then identify what has changed, because when you're transforming, you're looking for things that have changed. So we're starting at our parent function. Well, the A value, this should have an x squared, because we're doing quadratics, and we know that our parent function is y equals x squared, f of x equals x squared. So your A is your coefficient of x. So my A is positive for my parent function. And then we're going to do the A value. Okay, the value or the coefficient is just a 1. Your h is the number inside the parentheses with x, but I don't even have parentheses here, so my h is 0. And then your k is your constant out to the side. And again, do I have a plus or minus number out to the side? I don't, so my k is 0. Okay, so now we're going to look at our new function, and we're going to identify our a sign, our a value, our h value, and our k value. So now my a value is negative. The absolute value of -3 is +3. Remember, this is your h, the number in the parentheses is your h, and you always do the opposite of anything in the parentheses. So the opposite of a +4 is a -4. And then my k is a constant out to the side, which I don't have one. Okay, so I listed out all my original values and all my new values, and now we're going to identify what changed. So my a went from positive to negative. Remember, your a sign tells you which way you're opening. If a is positive, opening up. If a is negative, you're opening down. So since the a sign changed, we reflect over the x-axis. It's always over the x-axis. Okay? And then my a value went from a 1 to a 3. My a value got larger. If it gets larger, you're stretching. So we're going to say a vertical stretch. By how much? 1 times what gives you 3, so by 3. If I multiply my 1 by 3, I get 3. So that's how I know I vertically stretched by 3. H, which is the x value of your vertex, and x is your horizontal axis. If your x changes, you change or you shift horizontally. So I went from 0 to -4. On your x-axis, -4 would be to the left. So I'm going to put shift left. You're not going to say left -4 because the left already implies that you're going to the negative. Okay, so it's just shift left 4. And then my k value didn't change, so I'm not going to say anything about that. What does k do, though? K is the y value of your vertex, and y is your vertical axis, so this would shift you up and down, because up and down is a vertical movement. Okay, so you have 4 possible transformations, which is why we listed out our 4 critical values. Okay, you won't always have 4, but you always want to make sure that you check. Okay, number 12. We are still starting at our parent function. All of them in this section, we're starting at our parent function. So my a is positive. The value of a is 1. H is 0. And k is also 0. So then we're going to look at our new function. Remember, a is always attached to your x squared, and f of x is representing your x squared. So 1/2, that's a positive. The value of a is now 1/2 because it's the number multiplied by your f of x, or the x squared. Your h is the number in the parentheses. Well, I only have x in the parentheses, so my h is 0. K is the constant out to the side, so k is -8. And -8 is not in the parentheses, so we don't do the opposite. We do exactly what it says. So my a sign didn't change. Both the a's are positive, meaning both of these parabolas will open upward. The a value did change. Remember, your a value affects the width. So did it get bigger or smaller? From 1 to 1/2, it got smaller, so that's a vertical compression. By 1/2. 1 times 1/2 is 1/2, so that's why it's a vertical compression by 1/2. You could also hear words like vertical shrink or narrower, or sorry, not narrower, that'd be the opposite. So a vertical compression would be fatter, wider, or a vertical shrink. My h value did not change, so we did not shift left or right, but this time my k value changed. Remember, k is the y value of your vertex, y is your vertical, so we go up and down. If k goes from 0 to negative 8, we're going down. So we're going to say shift down 8. Again, don't put negative 8 because the down means that the 8 is negative. Okay? So that is how you describe the transformations. Now we're going to move on to where you write the new equation given a transformation. Okay, we're still starting the same way as we did in the last section. We're going to list out our a sign, our a value, our h value, and our k value of our original function. So looking here, remember a is your x squared coefficient. So my x squared coefficient is 1, meaning a is positive. And the value of a is 1. Remember, h is the number in the parentheses with x, but I don't have parentheses, so my h is 0. And then my k is the constant out to the side, which my constant out to the side is 3. And it's not in the parentheses, so we don't do the opposite. Okay, so if it says left 2, that means that is my h value. H affects you shifting left and right. And if you go left 2, that's a negative 2 because you find negative numbers to the left on the x-axis. So 0 minus 2 is now negative 2. But then we also need to shift up 5. Shifting up and down is your k value. If I go up, I'm adding. So I'm going to add 5. So 3 plus 5 is then 8. It doesn't say I make any other changes. So these are my only 2 new values. So what I'm going to do is I'm going to write my vertex form, and then we're going to substitute in our values and see if we can simplify. So y equals a times x minus h squared plus k. So let's substitute our values in. We have y equals positive 1. Do you have to put a coefficient of a positive 1? You don't, so I'm not going to put it. Then I have x minus, my h is a negative 2. So a minus negative becomes a plus 2. Squared plus k, which k is 8. So this would be my new function if I transformed y equals x squared plus 3 by shifting it left 2 and up 5. Okay. So now we are going to write equations giving a vertex and an ordered pair. So I'm always going to label my vertex as h, k. And then label your point as x, y. So then we're going to write our equation in vertex form. So y equals a times x minus h squared plus k. We're going to substitute in all the values we know. Well, we know all of our variables value except for a. So this process is to calculate what the a value is. Because when you're writing an equation, you have to have your a, your h, and your k. I only have my h and my k. This x and y value is going to help me calculate my a value. So instead of y, I just label y as negative 2. So I'm going to do negative 2 equals a times, I just labeled x, 1, minus h, which h is 0, because h is 0, squared plus k, which my k is a negative 4. So I substituted all my values properly. Now we need to simplify. So negative 2 just stays negative 2, and I get equals a times 1 minus 0 is 1. 1 squared is just 1. And then positive negative 4 just becomes a minus 4. Okay, I need to get a by itself, so I need to get rid of that minus 4. So I'm going to add 4 on both sides. So negative 2 plus 4 is 2. So I get 2 equals, over here, the negative 4 plus 4 cancel, and a times 1 is just a. So I now have the a value for my function. So I'm just going to rewrite my function. And remember, when you're writing your equation as your answer, you only need the a value, the h value, and the k value. This x and y was just to help me figure out my a value. So I'm going to leave it as y equals, a is 2, so 2 times x minus h, which is 0, squared plus k, which is negative 4. Now, we can simplify this a little bit. So let's do y equals 2. Do you need to include a minus 0? You don't. So if there's no minus 0, if there's no number in the parentheses with x, you don't need the parentheses. So it's just going to be y equals 2x squared. And then again, my positive negative 4 just becomes minus 4. Now the great thing about this, guys, is you can graph this on your calculator. Make sure it has the vertex of 0, negative 4, and that the point 1, negative 2 is on the table as well. So I'm going to go to my calculator, and I'm going to type in 2x squared minus 4. I'm going to pull up the table. Is my vertex, in fact, at 0, negative 4? Well, is that where I see symmetry? 4 and 4 match, negative 2 and negative 2 match, 0, negative 4. Yes, my vertex is in the right spot. And then do I have the ordered pair 1, negative 2 on my table? I do. So I know that this equation is correct. Okay. Now we are going to write our equation in vertex form from a table. Okay. So you need to make sure you can identify where the vertex is. Remember, your vertex is the one that doesn't have a partner. It's being sandwiched by pairs of y values. So 16 and 16 match, 7 and 7 match. So here is my vertex. Okay, so I'm going to label that HK. So this is my H value and this is my K value. Then we're going to pick another point and we are going to label that X, Y. I just always use the point right below it. Could you use a different point on the table? You definitely could. Okay, so then we have y equals a times x minus h squared plus k. So that is your quadratic vertex form. So now we're going to substitute the values in that we just labeled here. Just like in the last problem, we're using these values to help us find the a value. So y is 7 equals a, which we don't know, times x, which is 0, minus h, which is negative 1, so minus a negative becomes plus 1, squared plus k, which k is 4. So we're going to solve this for a. 7, just a 7, equals a times 0 plus 1 is 1, squared is 1, plus 4. So we need to get a by itself, so I'm going to subtract my 4 on both sides. 7 minus 4 is 3. And then also your a times 1 is just a. So therefore, a is 3. So we're going to rewrite our equation, and we're going to leave x and y as the variables x and y. We are going to replace our a with 3, our h with negative 1, and our k with 4. So we have y equals a, which we just found to be 3, times x minus h we have labeled as negative 1, so minus a negative becomes plus 1, squared plus k, which we have k labeled as 4. So there is my answer. So again, you could go to your calculator. You could graph or type in your equation. So I have 3 times x plus 1 squared plus 4. And I'm going to pull up my table. And I should see the point. Negative 316, negative 27, negative 14, 0, 7, and 116. Remember, if you're doing your test at home on Canvas, you can always use Desmos if you don't have a calculator. Okay? So that is how you write your equations. Now we are going to have our equation in vertex form, and we are changing it to standard form. Remember, standard form is y equals ax squared plus bx plus c. Okay? So essentially what we need to do to get from vertex form to standard form is we need to get rid of the parentheses. Remember, when you have parentheses to the second power, write your parentheses out twice. So I have y equals 2 times x minus 4 times x minus 4 plus 1. When I have 2 terms times 2 terms, you can box it or you can double distribute it. I'm leaving the 2 out in front. I'm going to double distribute. So x times x is x squared. X times negative 4 is negative 4x. So I'm done distributing my x to my 2 terms in the second parenthesis. Now I'm going to distribute my negative 4. Negative 4 times x is negative 4x. And then negative 4 times negative 4 is positive 16. And then don't forget to tack on the plus 1 outside the parentheses at the end. Okay? Well, we need to simplify our parentheses. So I have y equals 2 parentheses x squared. These are like terms, so I'm going to combine them. So negative 4x minus 4 more x's is negative 8x plus 16. Still in parentheses because I have this 2 next to it. So I need to distribute that 2 to every term in the parentheses. So 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. 2 times 16 is a positive 32. And then tack on that plus 1 at the end. We're not distributing the 2 to the positive 1 because the positive 1 isn't in parentheses. But now we have these 2 that are like terms. So we have one more step. Y equals 2x squared minus 16x plus 33. Now, a lot of these on your test, you can check yourself. These should be the same functions. These 2 are the same functions. This isn't vertex form, this is in standard form, but they're both representing the same function. So I'm going to go to my calculator, and I'm going to type both of these in. So 2 parentheses x minus 4 squared plus 1. And then I'm going to type in 2x squared minus 16x plus 33. And I'm going to pull up the table. And if you notice, the y1 and y2, this is the y values for the first function you put in. These are the y values for the second function you put in. Do those y columns match exactly? They do, meaning these are the same functions. So we did it correctly. Okay? So you can use the calculator on a lot of this test to double check your work. Okay. The next, it says state the domain and the range. Remember, domain is x, range is y. So looking at this picture, I know that this is a quadratic because it's making that U-shaped curve that we call a parabola. So I know this is a quadratic. Normally for quadratics, my domain is all real numbers, but see how we have endpoints here. So that means my domain isn't going to be all real numbers. Remember, domain is x, so I'm going to go along my x-axis and draw a line at the furthest to the left and the furthest to the right. So all my x values are in between negative 3 and 2. So this is when we're going to use our compound inequality. So negative 3 is less than x is less than 2. My x values are in between the small number, negative 3, and the biggest number, 2. Remember, we always use less than signs because small numbers are always less than the big number. Okay, now we need to determine if we should put equal to's on either of these. So at -3, I have a closed dot, meaning we're including it. So I'm going to put an equal to line there. At 2, we have an open dot, so we're not going to put an equal to on that one. Okay, now let's do our range. Range is y, which is up and down. So I need to draw a line at the very top and the very bottom of my function. This is at 4, this is at -5. So it's -5 is less than y is less than 4. Now we need to determine if we should put equal to's. At -5, we have a closed dot, meaning we're including -5 in our answer, in our range. So I'm going to put an equal to. Up here, you don't really have a closed dot, but does my parabola actually get to a y value of 4? It does. It has a point on there at 0, 4, meaning the y value is 4, meaning we need to include 4. So I'm going to put the equal to there. Okay? So let's go on to the last page. We're going to do all of these. Number 24 says, a cheerleader throws a pom-pom in the air. The height of the pom-pom is described by the equation h equals 20t minus 5t squared, where h is the height of the pom-pom in meters and t is the time. So h is the height and t is the time in seconds and in meters. Okay? So we have this equation. I'm going to write this over here so we can see it all in the same screen. So h equals 20t minus 5t squared. Okay? So how high is the pom-pom after 2 seconds? Well, 2 seconds. Seconds is my time. So this is my t. So I'm just going to rewrite my equation. H equals 20, not times t, but I'm going to replace t with 2. Minus 5 times, not t, but I know t is 2, and this one's squared. So h equals. So I can go to my calculator and do 20 times 2 minus 5 times 2 squared. 20 times 2 minus 5 times 2 squared. And we get a height of 20 meters. Okay, the next one says, what is the maximum height? Remember, our maximum happens at the vertex, okay? So I'm going to have to use that x equals negative b over 2a formula, okay? So let's look. We have h equals 20t minus 5t squared. This is not in standard form because my t squared is after my t term. So I'm going to rewrite this as h equals negative 5 t squared plus 20t. So that way it's easier to see what my a value, my b value, and my c value is. Okay, so this is my a value, this is my b value, and my c value is 0 because I don't have one. Okay, so we're going to use this formula, x equals negative b over 2a. X equals negative b, which is 20, over 2 times a, which is negative 5. So that gives me negative 20 over negative 10, which means x is 2. Okay, so it says when does it reach a maximum height? It's not asking yet for what the maximum height is. So in this case, time is your x and height is your y, because your height depends on how long the pom-pom's been in the air. Okay, so this is my time, so 2 seconds. But now I need to also figure out what the height is. Okay, so we are going to plug our 2 back into our function. So I have h equals 20 times 2 minus 5 times 2 squared. So my height is, well, if you look up here, aren't these the same exact things? So my height is 20 meters. So we're going to answer the question by saying, at 2 seconds, you reach a max height of 20 meters. Now, you can also graph this, okay? So we can put this in our calculator and pull up the table. Whenever I go to my y equals, though, I can't use the variable t. The h is my y, the t is my x. So I'm going to type in 20x minus 5x squared. And when I pull up my table, I should have a point at 220. Also, you can look, is that 220 your vertex? Is it being sandwiched by pairs of y values that match? It is, so that 220 is my vertex. And remember, your max and min always happen at the vertex. So if we're asking for the max, we're looking for where the vertex is. And our calculator confirmed that our vertex is at 220. So we know our answer is correct. Okay? On to this next one. I will tell you, you're going to have one super similar to this on your test. I'm going to zoom out a little bit so we can see the question and the graph all at the same time. Okay. At what time does the ball reach a maximum height? Remember, your maximum happens at the vertex, so right there. So if I follow that down, it's in between 1 and 2, so at 1.5 seconds. Okay, the next one, at what time is the ball at 30 meters? So I'm going to go over here to my meters, which it's labeled on my y-axis, go to 30, which is right here. I'm going to follow that across. Look, it hits your graph at 2 points. So I should have 2 answers here, okay? Because remember, quadratics all have pair points, okay? Every point is reflected over that axis of symmetry except for the vertex. So if it's saying at what time will the ball be at a height of 30 meters, it's going to be at 1 second and at 2 seconds. So you have 2 answers there. Make sure, a super common mistake is we just find the first one, it's going to be at 30. Follow that line all the way across and see if it hits your parabola in more than one spot. It normally will because, again, our parabolas show reflection. Okay, 27. How long is the ball in the air? So when is the height 0? Because if the height's 0, it's no longer in the air. So down here is a height of 0. So right there, that's where it hits the ground, which is 4 seconds. The ball was in the air for 4 seconds. Okay? Next one, last one. Number 28, it says the table shows how wind affects a runner's performance in the 200-meter dash. Positive wind speeds correspond to tailwinds and negative wind speeds correspond to headwinds. The T in finishing time is the difference between the runner's time when the wind speed is S and the runner's time when there is no wind. Based on the table, write the quadratic equation that best fits the data. So, write a quadratic equation that best fits the data. That is doing quadratic regression. So we're going to go to our calculator and we're going to go to Edit. We need to clear out our lists. You highlight the L1, highlight the L2, hit clear and enter, and it will clear the whole list. Okay, so we are going to put in 20, 30, 40, 50, 60, and 70. Okay, those are my X values, or my L1 values. Then we're going to arrow over, and I'm going to do 372, 462, 509, 501, 437, and 323. Now, if you don't have one of these calculators to take your test, remember in the lesson for today, Ms. Humenek showed you how you can do this same exact thing on Desmos. Okay, so you don't have to have the TI-84 plus calculator to do this. You can use the Desmos, which will be linked on the test on Canvas. Okay, so after you input all the data, we go back to Stat. We don't need to edit anymore. We're going to go over to Calc, and we are doing Quadratic, so we're going to go down to the quad regression. And then we get this screen. You just hit enter a bunch of times until you highlight calculate, and we want to calculate. So look, it tells me my A, B, and C values. So we are going to write this rounding each value to the nearest hundredth. So we're going to say A equals negative 0.26. The 4 doesn't round the 1 up, so 1. B is 22.5914. The 4 doesn't round the 1 up, so it stays a 1. And then C is 23.02. The 5 rounds the 8 up to a 9. So there are my values, okay? Again, our equation is y equals ax squared plus bx plus c. And if you forget it, it's also right here. When you do quadratic regression, it gives you the standard form of it. Okay, so we're going to just substitute our values in. Y equals a, which is negative 0.261, x squared, plus b, which is 22.591x, plus c, we're kind of running out of room, so plus 23.029. Sorry, I kind of had to smush it in there a little bit. So there we go. That is your quadratic regression equation. Now, if I were to graph this and pull up the table, I wouldn't necessarily see these exact values, because in the real world, you're not going to be able to find an equation that exactly fits your quadratic data, because it's not going to be perfect. This is the best fit for the data. So if I did graph this and pull up the table, I could go to x being 20 and I would have a y value pretty close to 372. I could go to x being 30 and I would have a y value pretty close to 462. Okay? You will have one of these on your test. This one will not be multiple choice. So please make sure you know how to do this on the the TI-84, or if you don't have that calculator, that you know how to do this on Desmos. If you need help on how to do it on Desmos, again, refer back to the lesson video for today, or reach out to your teacher, okay? Good luck on your test. The full answer key to the review will be online as well. Hope y'all have a great day and good luck on your test.